Welcome to video 4.4 on covalent bonding and oxidation numbers. In this video, you're going to be able to identify which type of compounds are covalently bonded, hence using the type 3 nomenclature. In this video, you will also use that type 3 naming rules to identify the names of the compounds and then also turn around and write out their chemical formulas. The final part of this video will be able to learn how to assign oxidation numbers to different compounds. As a reminder, oxidation numbers can be found on your periodic table, but now we're going to go into how to assign them and even where they came from. So here are the key vocabulary terms: type 3 compounds, molecules, prefixes, oxidation numbers. Again, if you're struggling with any of these, pause the video, check out Google real quick, and come back to us. So type 3 compounds. Type 3 compounds is what we are classifying as molecules. So remind you, a molecule is any compound that is covalently bonded. So if I have a covalent bond, that compound is referred to as a molecule. One other way to recognize type 3 compounds is they will always start with a nonmetal. In our ionic bonds or in our ionic compounds, we started with some kind of cation, some form of a metal. Here though, in type 3, our molecules, you will notice I have carbon in my example, or I have nitrogen. Both of these guys are to the right of the stairs and are nonmetals. So again, what's a molecule? It's things that are covalently bonded. How can I recognize if something's a molecule? Because I can look at the difference in electronegativity, or I can even just see that it starts with a nonmetal and not a metal in the chemical formula. So how do we name these? Type 3 naming just relies on the use of prefixes. A prefix is when we add the certain word combination or certain letter combination to the beginning of a word. So again, this eliminates the need to use Roman numerals, but what it does is it gives us just a very clear way to name compounds by using a prefix. So to the right are the 10 prefixes you need to know. So these are something you do need to commit to memory if you don't have them known already, and they need to be very easy for you to use and go back and forth. You should pick these up as you do your homework, but again, maybe take a moment to look through them and to get them down. So an example here is we have carbon, and there's only one carbon. So the prefix for one is mono, but again, just the naming rules is we don't include mono on the first chemical. So for example of this, we have carbon, we have chlorine. Remember, we changed it from chlorine to chloride. And then since we have a 4 here, we're going to use the prefix tetra. So how would I name CCl4? It's just simply called carbon tetrachloride. So reminder, we just named the first element first. We name the second element second. We change that ending on that second element to "ide," and then we include prefixes where necessary. The only rules here are we don't use mono for the first element. It's a little redundant, but you would use mono on the second word when it applies. And then also another quick word or a rule here is we will drop the vowel sometimes. When you get things like carbon monoxide, you don't say monoxide. You just drop that double O and you only leave one O there in its place. So let's go ahead and practice. You can go ahead and try this yourself. Maybe try 1 or 2 or 3 and then pause the video, and then I'll show you how to do it with my own hand. All right, so as we look at this, the first one here is of P. You should recognize from your periodic table that that is phosphorus. Since there's only one P, we would put mono there, but the rules say that we don't. We skip that step because it's redundant. So we would just label this as phosphorus. And then we do have a 5 here, so I need to put the prefix penta, which I see right here. And then again, it's not chlorine, but it's going to be chloride. Phosphorus, pentachloride. Next one you've already seen, a 2, so that would be di. We have hydrogen. And then again, there's a 1 here, so we do include the mono because it's the second one listed, but I do not double up the O. I actually drop the O off mono, and I just go monoxide. Oops, I even almost made that mistake myself. Final one, I have carbon. Carbon has 4, so we're going to call that tetracarbon. And then there's a 7 here, so it's going to be heptanitride. Again, not nitrogen, but nitride. So I have tetracarbon heptanitride. So again, your job is going to be able to take this and name it by having this committed to memory. And then you need to go in reverse. Here we have nitrogen, dinitrogen pentoxide. So how do I write this formula out? Well, first of all, I know nitrogen is an N. That di tells me it's a 2. Pentoxide, so that's oxygen. The pento tells me there's a 5. Again, notice how they dropped the double vowel. They dropped the A here and just called it pentoxide. The next one, carbon, since there's no prefix, it's just a 1. Hexafluoride, so we put our F. We see hexa is a 6. Bam. Last one, carbon, tri, so there's a 3 there, and a hexahydride. So I have my H is hydrogen, which is a hydride when it's an anion form, and it's a 6 here. Very good. All right, so now as we move on, that is your naming, and again, there'll be a homework associated with that. But as we look at these, we can again see that these guys are coming together in these unusual combinations. They are coming together to create oxidation numbers that are different than what we would predict them to be if we're looking at our periodic table. So what part of this lesson now is going to be how to assign oxidation numbers. When we look at something here, we see oxygen and nitrogen both do not follow the trends on the periodic table. Again, if you looked at your periodic table, you would know that oxygen is going to be a -2. But here, nitrogen is not its most common -3. So how do I determine which oxidation numbers to assign here when they don't follow the pattern that the periodic table sets out? And that's what I'm about to show you. So again, what's an oxidation number? An oxidation number refers to what the electrons are doing. It refers to this idea of how many electrons were either gained or how many electrons were lost and what kind of charges that element would form when it becomes inside a molecule. These are similar to formal charges. You'll hear more about formal charges in the future. A formal charge is the actual charge an element has when it's in a compound. An oxidation number, again, they're the same thing basically, but oxidation number more references what did the electrons do. And again, all these oxidation numbers can be explained by looking at the orbital notation or even the electron configuration. If you think about the valence electrons and you think about the different suborbitals of S and P, you could look at the orbital notation and explain why these elements are willing to gain or lose electrons to not just obey the octet rule, but just to get rid of an orbital or so on. So here are some rules over here to the right about oxidation numbers. If something is an element form, if something is neutral, and there's only one atom of that kind, it's not an ion, then there's not going to be a charge. So on your periodic table, when you look at all the elements, they all have an oxidation number of 0. But then when they become an ion, that charge that they form is their oxidation number. So the charge of an atom, when it becomes an ion, that is the oxidation number. And again, it is referring to the amount of electrons that are either lost or gained, and typically lost or gained to obey the octet rule. So a couple other things you see here, and this is somewhat review. Look at group 1, lithium, sodium, potassium. Those will all be +1. They'll all have an oxidation number of +1 unless they're just the element. Because again, if it's just the element, if they're neutral, their oxidation number would be 0. Group 2 would have an oxidation number of +2, again, unless they're an elemental form. Then they'd be oxidation number of 0. Hydrogen mostly will have a +1 oxidation number, but that's when he is bonded to a nonmetal. So when hydrogen is bonded to something to the right of the stairs, he's going to have a +1 oxidation number or a +1 charge. But when he is bonded to a metal, hydrogen can actually take a -1 oxidation number. And again, that's when he's bonded to a metal. And again, as you use these, you'll instinctively be able to follow these rules. But this is the formal way of seeing and looking at all these rules. Oxygen will almost always be -2. The only time he'll become a -1 is when he exists as a peroxide. So he does have this ability to form one of your polyatomic ions called peroxide. He also forms hydrogen peroxide, which you've heard of before, but it's this idea that he will have an oxidation number of -1 here. That's very rare. So really think of oxygen as a -2. Fluorine will always have a -1. Why will he always have -1? Because he has the highest electronegativity, so he always gets to dictate what he wants his charge to be. And so fluorine will always be a -1. And then again, if I ever have a neutral compound, this neutral compound, the oxidation numbers inside that compound will always add up to 0. So because a compound is neutral, the summation of all those oxidation numbers needs to be 0. Again, you'll see this again as I practice this. Looking at ionic compounds, the same thing. If that ionic compound is neutral, then all the oxidation numbers need to equal up to 0. Or if I'm dealing with something like a polyatomic ion, which I'll show you in a second, if it has a charge, if that polyatomic ion has a charge, then the oxidation numbers of the elements inside that have to equal the charge of that polyatomic ion. So I'm going to show this to you. Again, this will all make sense as you see it in practice, but these are the rules that you can come back and think of. All right, so oxidation numbers. How do we do it? Well, we're going to assign oxidation numbers to carbon tetrafluoride here. How do I name that? Carbon tetrafluoride. So how do I say what's the oxidation number of that carbon and what's the oxidation number on that fluorine? Again, if you look at your periodic table will show you the different oxidation numbers that each element could have. And if you look at fluorine, you will notice again that fluorine only has one oxidation number, so fluorine will always be -1. But now, what about carbon? Carbon has multiple oxidation numbers. Carbon has 3 oxidation numbers to be exact. Carbon could be a +2, carbon could be a +4, or he could be a -4. And again, you can explain those numbers based on the orbital notation, based on the octet rule, or just losing suborbitals. But that's not really what we're doing here. Just keep that in the back of your mind. So as I look at carbon, I need to dictate what's his oxidation number because I know fluorine is already a -1. So when I add this up, all these oxidation numbers need to add up to 0 because, again, this is a neutral compound because there is no charge in this top right corner. So because I know fluorine is a -1 and because I have 4 fluorines, 1, 2, 3, 4, all I have to do now is calculate the value of carbon. What is carbon's oxidation number? And in order for loss to be 0, carbon has to have a +4 oxidation number. So I'll give you some more practice here in a second. But this is all you do. Just set up an equation equal to 0, label out those oxidation numbers, and then find that unknown to make sure it equals 0. Remember, as you do this, if you're not sure where to start, look for the element that has the highest electronegativity. He gets to pick his own oxidation number. That's why fluorine will always be -1 because he'll always have the highest electronegativity. Oxygen will almost always be -2 because he gets to pick, and when oxygen gets to pick, he's going to pick -2. So as you start with this, whoever has the highest electronegativity, they're going to pick the charge that I already taught you, the one that you would see based upon the octet rule and based upon what you see in your periodic table. All right, so let's go ahead and practice. I'm going to show you the answers here. If you want, just do one by yourself, or you can watch me do the first answer, but eventually you need to pause and you need to practice these on your own. So go ahead and pause the video if you're ready, and then I'll explain how to do these. Welcome back. All right, so now as we look at how to assign oxidation numbers. All right, again, the first step you want to do is you want to begin to set up your equation. Since this is a neutral compound, I'm going to set up an equation that is equal to 0. Here you can see that this is a polyatomic ion, so here my equation would equal -3. Down here, again, it's neutral, so that one would equal 0. So as I go back here and as I want to assign oxidation numbers to each individual element, we have to start with whoever has the highest electronegativity. So I look here and I say oxygen is higher electronegativity than nitrogen. He's closer to fluorine, so oxygen gets to dictate his own charge. And if oxygen gets to pick his charge, he is going to pick -2. Again, these guys, if they get a pick, will pick -1. If these guys get a pick, they'll pick -2. If these guys get a pick, they'll pick -3. So if oxygen is going to be a -2, we start to add that into our equation. I have 3 -2 charges here. Now, let's go ahead and we're going to add all these up and try to get them to 0. Let's look at hydrogen. Hydrogen will be a +1. Again, the only time he might switch to a -1 if he's with a metal. We're not dealing with metals here. We're dealing with covalent compounds, so he's always going to be dealing with non-metals in this situation. So hydrogen is first, plus we always list the positive charges first anyway, just like in the ionic compounds. So here we see hydrogen as a +1. So the only thing left to figure out now is nitrogen. What is nitrogen's oxidation number going to be? Well, here you just do a little math to figure out what number this has to be to equal up to 0. So 3 times -2 is going to give me a -6. I have a +1 here. So in order for this all to equal 0, you can see nitrogen needs to be a +5. So then you would say hydrogen has a +1 oxidation number, nitrogen has a +5 oxidation number, and of course oxygen has a -2 oxidation number. And this is what I'm looking for as the answer. All right, Pause the video if you want. Try it, the last two by yourself. But then when you're ready, regain the video and I'll show you how to answer them. Okay, welcome back. Again, oxygen has a higher electronegativity than phosphorus. So therefore, I'm going to start with oxygen. He gets to pick his charge. He picks -2. So if he picks -2, I see I have 4 -2s here. And so then now I just got to figure out what's my phosphorus. Well, if this comes out to -8 and it needs to end up with a -3 because the overall charge is -3, what number do I need here to make this true? That would be a +5. So phosphorus here is a +5, and oxygen here will have an oxidation number of -2. Last one, again, we're going to start with oxygen. I have 4 oxygens times that by -2. So that gives me a -8 charge overall. I know sodium is going to be a +1. That is almost always. Not almost. He will always be a +1. And so then now I'm just trying to figure out, well, what's this sulfur here? What is this unknown sulfur oxidation number? It's not it. That's an S. And so then 2 + 1 is a +2. Now I just need to say, what number do I need here to make this a true statement? And again, it would be a +6. 2 + 6 - 8 = 0. So again, oxidation number of sodium is +1. Oxidation number for sulfur is +6. Oxidation number for oxygen is -2. I hope you see that oxidation numbers is not too complicated. You just got to do it a few times. These rules, like I said, will become very instinctive because you already know most of this stuff. The only really new trick you need to make sure you follow is just start with your highest electronegative element. Let him dictate his charge, and then everybody else will fall in line, and then just set up your equation. So what was this video about? It was about how to identify type 3 compounds. You're going to be able to identify them because you know those are going to be molecules because they are bonded covalently, or you can identify them because they don't have any metals in them, that they have no metals listed in that compound anywhere. So therefore, it's going to be a non-metal or a covalently bonded compound. You also in this video saw that prefixes can be used to determine the number of atoms in a molecule. And so we can use that prefix in our naming system to easily show the number of atoms within a molecule. Then also you can see oxidation numbers. We learned how to assign them following the set of rules I gave you. Namely, fluorine will always be -1, oxygen will always be -2. And if you're ever in doubt, start with the highest electronegative element, but then just set up all their charges equal to 0 for a neutral compound, or set up an equation equal to the charge in that ion, and you can easily figure these out. Thank you. Have a great day.